So when I see a problem like this one, I like to rewrite the entire thing, first of all, as one big fraction, because that's how you're kind of used to seeing it, right? And then I take my negatives, any of the negative powers, and I move them to the opposite side. I don't even bother trying to add and subtract exponents using the properties. I'm dealing just with the definitions. And the definition says that when you have a negative power, it can move to the opposite side of the fraction bar and become a positive power, right? So that x to the 6th stays down here, but the x to the 4th comes down, and so does the y to the 3rd, because those were negative, and this one went up.
That one's a y. One on top with the 7.
Oh, this should be a y, right?
Yeah.
So did I do something wrong? Yeah, this is a y. Yeah, my bad. Okay. And now I just use, again, I'm not even using the properties, I'm just using the definition. How many, let's deal with the numbers first. Can I cancel any of these out? That's just 5, 2, 5, 2, right? 25 and 4. This is just 7 and 11, 7 times 11. So those don't cancel out. How many y's do I have in the, so my numbers are going to stay as 100 over 77. How many y's do I have on the top
7.
and on the bottom?
3.
So how many cancel out? 3, and how many are left? 4 on the top. That's how I do it all the time. Just, to me, it just makes it so much simpler. And how many x's do I have in total?
10.
And where are they?
On the bottom.
Good. That's how I would do that problem.